Okay, let's finish the last 10 problems of the Math 120 practice midterm. So number 41 says you've got the function f of x is 5x plus 7, and we want to evaluate f of 4 minus f of 2. In other words, if you put a 4 in there, what do you get? And if you put a 2 in there, what do you get? And then you subtract them. So you put a 4 in there, and you're going to get 5 times 4 is 20, plus 7 is 27. Put a 2 in there, you're going to get 2 times 5 is 10, plus 7 is 17. And so you subtract them and you're going to get 10. And that is something we could have gotten easier just by realizing what this function is. This is just a line, and the slope of the line is 5. And since the slope of the line is 5, that means that for every unit that I move on the x-axis, it's going to move 5 units on the y-axis. You're going to add 5 to the function. So in moving from 2 to 3, I added 5, and from moving from 3 to 4, I added 5. Here's f of 2, here's f of 3, there's f of 4, and each one of those gave you 5 more, so it was a total of 10, which you get by taking 27 minus 17. This would have been a 22 right there when you put in a 3. 3 times 5 is 15, plus 7 is 22. So every unit you move over, the function goes 5 units up. Okay, so that's that one. Now let's compare that with 42 rather. 42 says, what if we have the function f of x is equal to 5 to the x power plus 7? How does that affect things when we go from 2 to 4? Well, let's do it. I guess this is the function g instead. G. So here we have g of 4 minus g of 2. So g of 4 is going to be what you get by taking 5 to the 4th power. What's 5 to the 4th power? 5 times 5 is 25. Multiply it by another 25, and you get another 5, and you get 125. And you multiply that by 5 one more time, and you get 625. So 5 to the 4th is 625, plus 7 is 632. Put in a 2 here, and you get 5 times 5, which is 5 times 5 is what? 25 plus 7 is just a straight 32. So you subtract the 2 and you get 600. And I guess the key to having these two problems right next to each other is that you see how much quicker, how much greater that function grows than this one. In this function, you just add 5 each time you go from 2 to 3 and 3 to 4. With the other function, you're multiplying by 5 each time. As you go from here to here, as you go from say here to here, from 2 to 3, essentially you multiply this number by 5, and then when you go from 3 to 4, you multiply it by 5 again. So instead of just adding 5 each time, you're now multiplying by 5 each time. So that's the difference between exponential growth and linear growth. This is exponential, this is linear. That's why you're always interested in anything that has exponential growth. You want to be careful about it because it could grow very, very quickly. We're in the midst of the COVID situation right now as I explain this, and so everyone is interested in exponential growth, because the more people that have as people have the virus and meet other people, they're going to spread it exponentially, and exponential growth can grow very, very quickly. Okay, so that's the idea. That's the difference between the two. So now let's do a little bit more with exponential growth. This is problem number 43. Problem number 43, a country's population in thousands closely fits the exponential function p of x is equal to 500. P of x is equal to 500, which means 500,000, e to 0.04 x. Okay, that tells you what the population is, and notice that that's going to be exponential growth as well. That's going to be a graph that grows like that. Okay, so so there it is, and we want to know, what do we asked? What's the number of years before it'll be 800,000? So x is the number of years. Usually we use t for time, but in this one, for whatever reason, we put an x there instead. So x is the number of years, and we want to know for what value of x is this going to be 800,000. These are all in thousands, okay? So when will it be 800,000? So we solve that for x. How do we do it? We divide both sides by 500, and we get e to the 0.04x is equal to 800 over 500. 800 over 500 is 8/5. 8/5 is 1.6. Okay? Now we want to continue to solve that, so the way we do it is by taking the ln of both sides. So we take the ln of e to the 0.04x, and that's going to be equal to the ln of 1.6. The ln of e to anything just cancels them out, and I get basically 0.04x. I'm sorry, 04x is equal to the ln of 1.6, and so x is equal to the ln of 1.6 divided by 0.04. And if you calculate that on your calculator, no way you can do that without a calculator. Let's go ahead and do it. You're going to get 1.6. I want to take the ln of that, and then I want to divide by 0.04, and I get 11.75. Rounds very closely to 11.75. Hopefully that's one of the answers. Yep, it is. That's the answer number E. Okay, very good. Let's do 44. Number 44. Oh, hold on just a second. Okay, back again. Number 44. An investment of $4,000. $4,000 is made at a rate of 6% compounded annually. So every year they add 6% to what's in the bank every year, annually. How much money will be in the account after 7 years? Okay, so pretty straightforward. At the end of 1 year, you take this $4,000, and to find out how much is in the bank after 1 year, you multiply that by 1.06. The multiplying 4,000 by 1 gives you the 4,000 back. That's still in the bank. And then multiplying it by the 0.06 gives you the interest. And so you multiply that out, and you're going to get, let's do it here, 4,000, 1.06, and you get $4,240. Okay, so that would be $4,240 by the time you have that in the bank 1 year. Now the next year, you got this much in the bank or this much in the bank, and you want to multiply that by 1.06 again. And we're going to do that for 7 years. Okay, 7 years. So at the end of the second year, this is how much money you have in the bank. Let me just write it like this. And you're going to take that and you're going to multiply that by 1.06. And that will be how much money you have in the bank at the end of the second year. At the end of the third year, you're going to multiply that by 1.06. And so you see that by the time you've done 7 years, you've got this original $4,000 and you've multiplied it by 1.06 7 times to the 7th power. So all we have to do is take 1.06, take it to the 7th power, do that again, and you get 1.5036, and then you multiply that by your 4,000. Looks like it's going to be a little bit over 6,000. 6,014 bucks and 52 cents. That's enough for a small candy bar. So let's see if that's in there. 6,014. Yep, there it is. See, very good. That's number 44. How about 45? Now we're getting into solving systems of equations of lines. Okay, you got 2 lines and you want to find out where they intersect, basically. So the first one says you've got y is equal to, this is number 45, and you've got y is equal to 2x minus 6. And you've got another line. Notice this is another line. Negative 1/2 x plus 4. And we want to find out where they intersect. So just real roughly, I'm not going to do a really good job on this, but to get a sense of what these functions look like, 2x minus 6, when x is 0, y is negative 6, so it's down there, and it has a slope of 2, so it's going to be going up kind of like that. And then how about this one? This one has a y-intercept of 4, and it has a slope of negative 1/2. Negative means it's going downhill, and negative 1/2 means it's not going downhill all that steeply. So something like that. So there's a pretty good idea of where that point is going to be. So how do we find it? Well, we want to find out what are the x values. What's that x value where the y values are the same? Notice the y value of this line has got to be the same as the y value of that line. So let me just say that again. What are the x values when the y value is the same? In other words, where will 2x minus 6 be equal to negative 1/2 x plus 4? So you can solve that lots of different ways. As I mentioned before, I don't like fractions. So I'm going to multiply this whole equation through by 2 and get rid of this fraction there, the negative 1/2. If I do that, I'm going to get 4x minus 12 is equal to negative x plus 8. So same equality there holds. It's just that I got rid of the fraction. Now I can add x to both sides, and I'm going to get 5x, and I'm going to add 12 to both sides and get 20, and then divide both sides by 5, and I get x is equal to 4. Oh, that looks about right. 1, 2, 3, 4. And what's the x value going to be? What's the y value going to be? If x is 4, you're going to get what? 4 times 2 is 8. 8 minus 6 is 2. So there's the point 42. It better be the same here. If I stick in an x equal 4 here, 4 times negative 1/2 is negative 2. Negative 2 plus 4 is again 2. So they both go through that point. That's where they intersect, right there. Okay, that's 45. 46. Now you've got a couple other equations. They're not set equal to y this time. So we could, if we wanted to, we could set them both equal to y and do it as we did before. We have 4x plus 3y is equal to 1. And we've got 3x plus 2y is equal to 2. Okay, so as I say, we could solve this one for y, we could solve this one for y, and then set them equal to each other. That would work. That's the way we did the previous one. But without going through all that problem, all that hassle, I think it's easier if we do this. It's called the method of elimination. So let's get rid of the y's. And you have 3 y's there and 2 y's there, so we need to manipulate these equations so we have the same number of y's. So let me multiply this equation here by 2. If I do it, I'm going to get 8x plus 6y is equal to 2. See that? And I'm going to multiply this equation. I'll do it by a negative 3. If it's a negative 3, it's going to be negative 9x. It's going to be a negative 6y. And negative 3 here is going to give me a negative 6. See that? And the reason for doing it is because, as I say, now I can just add these together. If I add them together, I'm going to get negative x. I've eliminated, hence the name, elimination. I've eliminated the y's, is equal to negative 4, and so x is equal to 4. Once you find x, then you can easily find y. If you stick a 4 in here, you're going to get 12 plus 2y is equal to 2. So 2y is equal to negative 10. Y is equal to negative 5. So y is equal to negative 5. As a good check, put it in here. Better work here as well. 4 times 4 is 16, plus 3 times negative 5 is negative 15. 16 minus 15, sure enough, is 1. So that's a cool method, okay? It works really slick. Okay, is that one of the answers? It better be. 4, negative 5. Yeah, very good. Okay, now let's use this problem to do an applied problem, okay? Or let's use our newfound knowledge of substitution and elimination to actually solve a problem. Number 47. At a Davenport rugby game, the bleacher seats cost $3 for a bleacher seat, and cushion seats cost $5. Okay? At the homecoming game, 50 tickets were sold, a total of 50 tickets, and by the time they looked at all the money in the till, they had a total sales of $180. Okay? And the question is, how many of each did they sell? Okay, how many of each did they sell? So, here's the power that you have as a mathematician, as someone who is doing a math problem. You can actually say let, and you can solve a problem in the real world by assigning a variable like x or y to some physical thing. So let's let x be the number of bleacher seats, bleacher tickets, and then we'll let y be the number of cushioned tickets. Okay? So there we've assigned a mathematical symbol to a physical thing. And that's how you use mathematics to actually solve real-world problems. So now, what's the reason for doing that? Because I know that the total of x plus y has got to be 50. We had a total of 50 tickets. So x plus y gives you 50. And the total cash is 180. Well, for each of these bleacher tickets, we made $3, right? So there's the amount of money we made on the bleacher tickets. And each of these cushion tickets, we made $5 on. So this is how much money we made for the bleacher. This is how much money we made for the cushion tickets. And that total was 180. So now we have, again, 2 equations and 2 unknowns. And so we have a couple options. I can solve them both for y and set them equal to each other. Or let's do it the way we did the last one. Let's multiply this equation by let's get rid of the x this time. We'll multiply this equation by negative 3. So if we multiply it by negative 3, we're going to get negative 3x minus 3y is equal to negative 150. See that? You keep this one exactly the same, 3x plus 5y is equal to 180. And what was the reason for doing it? Because now I can just add these two equations together, and I've eliminated my x's. Here I have 5y minus 3y is going to be 2y is equal to what? 180 minus 150 is 30. So that means that y is equal to 15. If y is equal to 15, then x has got to be what? 50 minus 15, which is 35. So apparently we sold 35 bleacher tickets and 15 cushion tickets. And again, you should just check it out here, see if it makes sense. 3 times this gives you 105 bucks. 5 times 15. You have 15 cushion tickets. Each one costs 5 bucks. So that would be 75. You add them together, sure enough, you get 180 bucks. So there you go. Okay, we're coming on towards the end here. That's number 47. How about number 48? Number 48. Let's see. Sarah just moved. Sarah just moved into a new apartment, and she's trying to decide which cable provider to choose. Cable company A charges an installation fee of 60 bucks and then charges $55 a month. Okay. Cable company B has no. Okay, we had a little technical hiccup here again. That's not a big deal. So the first company charges $60 for installation and $55 a month, and the second company has no installation fee and charges just a flat fee of $61 per month. And who is it? Sarah is going to stay for 6 months. So this is something that Sarah could figure out without talking about lines or doing any graphing. She could just say, well, what's the total cost going to be after 6 months? This one you'd take 60 times 55 and get the total charge from the monthly charges and then add 60 to that and get it. Or she could take 6 times 55, or take 6 times 61 and get that total charge. In fact, let's just do it. Let's just say total charge is what? No reason to make anything more difficult than it has to be. So A would be 55 times 6. So 55 times 6 is 330. So it's 60 bucks plus 330 is a total of $390 after 6 months. And B is going to be 61 times 6, which is 366 for 6 months. So obviously she's better off doing it this way. Okay, I guess let's just answer it like that. So so which one should she choose? Question is, she should choose company B. Okay, but now is a problem that you couldn't do just by doing it simply like this. You want to know, after how many months will they be the same? Okay, so at some point, do you agree? At some point, this is going to end up being a better deal. If you were to stay there for 50 years, then this $60 installation isn't going to be as important as the fact that she's got that lower monthly charge. So let's do it in terms of lines and see what this looks like. Okay, so here we are, and again, I won't try to do it exactly, but here's company A. Company A starts here with a fixed cost of 55 and then grows like this. Okay, it grows at a rate of $55 a month. So let's say that this is A right there. Company B has 0 charge but has a higher monthly rate. right there of $61 a month. So at some point, this is your number of months right here. Okay, at some point they're going to be equal, and then after that point, A is going to be the better deal. This one will be higher price than this. So let's get an equation for both of these. Y sub A is going to be $60 plus 55 times X, where X is the number of months. Okay? Y sub B is going to be just a straight 61X. Okay? So those are the charges for A, and those are the charges for B, given that she's there for 6 months. And we want to know, when are they going to be the same? So let's set them equal to each other. So we'll go 60 plus 55X is equal to 61X. And so I can subtract 55X from both sides, and I get 60 is equal to 6X, and then divide both sides by 6, and get X is equal to 10. So 10 months is the break-even point. At 10 months, they have the same charge. Past 10 months, she's better off to take A. So there you are. So that's number A. Okay, so that was number 49. So 1 to go. It's a cappuccino problem. I've never had a cup of coffee in my life, so I don't know anything about this. You'll have to excuse me if my mathematics is all wrong. Not having had a cup of coffee in my life and not having any this morning to wake me up. A cafe latte contains 25% espresso. So a latte contains 25% espresso. Is that high? I don't know. And a cappuccino contains 50%. A cappuccino contains 50% espresso. Okay, sounds kind of unhealthy. How many ounces of the latte and how many ounces of the cappuccino must be mixed together in order to get a 16-ounce drink? You want a 16-ounce drink. And that 16-ounce drink, you want it to be 40% espresso. Okay? So, well, shoot, as I say, I don't know much about this. First of all, it doesn't seem, why would a person even be interested in that? Are they interested in the percentage espresso, or are they interested in the total amount of espresso? It seems to me that they'd be interested in the total amount. So it seems like a better question would be something asking how much of each should they get so that they get a total of whatever, 10 ounces of espresso. So I'm not really understanding why a person would even be interested in this. But maybe espresso has a certain taste to it, and by the 40% makes it taste better or whatever. I don't know. So I'll just take the word of whoever thought of this problem and assume that it's a reasonable one. So anyway, let's figure it out. So so again, let's use the word let. We've got 16 ounces to work with, and so let's let X be the number of ounces of the latte, and then we'll let Y be the number of ounces of the cappuccino. Okay? And here's what we know. We know that what? We know that X plus Y has got to be equal to 16, right? Because we want a 16-ounce drink. So X plus Y has got to be 16. Now what else do we know? We also know that that if you take each of these ounces of latte and take 25% of them, and if you take each of these ounces of espresso and take 50% of them, that better be equal to 40% of the 16-ounce drink. So you know that as well. Agreed? So we know that as well. So those are our two equations. And again, I don't like fractions. So I'm going to make this, I'm going to multiply this whole thing by 100 and just get 25x plus 50y is equal to 40 times 16, whatever that is. I guess that's 6.4. That was easy enough to get. 640. 640. So there's our other equation. Well, so I'm going to get rid of this equation now. There's the 2 to work with, and let's see. These are awfully big numbers. Well, that's not a big deal. Let's just use them the way they are. And so here's what I'm going to do with this one. I'm going to solve this equation here for y, and get y is equal to 16 minus x. See that? I could use the elimination method again, but let's do this with basically another method yet, which is basically you solve this one for y, and now I'll just stick that value in right here for y. So I'm going to get 25x plus 50 times, what's y? 16 minus x is equal to 640. See that? So you've got that, and now you can multiply it all out. You're going to get 25x plus 50 times 16. What's 50 times 16? 800? That's 800. Minus 50x is equal to 640. And so I've got negative 25x plus 800 is equal to 640. Let's bring the 25x over to this side. And let's bring the 640 over to this side. If you do, you're going to get 160. And then you divide by 25, and you're going to get x is equal to 160 divided by 25 is what? 6.4. So 6.4 ounces of the which one? Of the latte. And you want 16 total, so this is going to be 9.6 of the espresso. So the latte is 6.4 ounces, and take 16 minus that, you're going to get 9.6 ounces of the espresso. And I think that's one of the answers. I'm sorry, the cappuccino. Very good. Okay, so go and enjoy your coffee product. You're all done with the midterm prep. So hopefully, make sure you know how to do all these, and you'll be all set for the midterm. Very good.